Okay, so here we have some uses for the half-angle formulas here. And we're going to start off with sine. And we notice that we have pi over 8, and we're like, what is that all about? But one way that we can rewrite this is the following, okay? So say if I have, I want to rewrite this as some angle divided by 2, okay? And so if I set this equal to pi over 8, and then I solve, I put the 2 over here, and I end up with theta equals pi over 4. Okay, so that's pretty interesting. So the way that we want to rewrite this then is going to be the sine of pi over 4 divided by 2. And the reason why we want that is because we'll have theta is going to be defined up top. So then we can just insert theta into the formula and knock it out. So let's do that. So I'm going to go plus or minus and start rolling out the formula as it states 1 minus cosine. And I know that theta is going to be pi over 4 all over 2. Okay, so now we have the plus or minus sign right here, and so what we want to do is that we want to pay close attention as we start to simplify this thing out. So if I have, we got this sine of pi over 2 here, and it's going to depend where the original angle. Now the original angle is going to be the pi over 8. We know that pi over 8 it has to fall in the first quadrant, right? Because it's in between 0 and pi over 2. So therefore, we know that it's going to be positive, so we can drop the negative sign and proceed from there. Okay? We still have some work to do, actually a little bit of arithmetic, and we'll see where that takes us. Okay, so now proceeding after we drop the minus sign or the negative sign, we have this guy. Right here, we know that it's 1 minus, and we got square root of 2 over 2, because that's what pi over 4 is. And then we got this. So now we have some algebra to do, or I should say some arithmetic to do. And so let's go ahead and start by, and I'm going to put this up here so we might have. So if I am going to, I'm going to do this off to the side and show you guys once in slow motion. So I got 1 minus root 2. So I want to get a common denominator with that 1 so I can combine these fractions. And so I'm going to write that as 2 over 2. And so that top is just going to be 2 minus root 2 over 2. Okay? So I end up with, again, some yuckiness, but that's part of the deal. So I got 2 minus the square root of 2 divided by 2 all over 2. So lots of stuff going on with that, and it's like, and just to make sure that you guys know where that came from, this part right here is this part combined up, and then of course the denominator is still the same. Now this is going to then start to, if I'm dividing by 2 right here, so this 2 is going to be multiplied by that one, okay? Because it would be like dividing by 2, flip it and multiply, so that would be like multiplying by 1/2, okay? And so I end up with 2 minus the square root of 2 all over 4. Now I can take the square root of 4 and the top part separately. So that's going to give me 2 minus the square root of 2 divided by the square root of 4, which is going to, at the end of the day, give me 2 minus the square root of 2 all over 2. Okay? So the way that you can check that is that you can put this right here into your calculator and put this into your calculator, and they will come out the same. Okay, So that's how you do that guy. And so let's take a look at how we would tackle a tangent one. Okay, so I like the tangent ones a lot more. Seem a little bit easier, and I'm going to recommend, if you can, that you use this form. It seems to be the easiest of the forms for students to go ahead and grasp and whatnot. So let's start off by finding out what theta is going to be. So we want to set theta divided by 2 equal to whatever angle that we got sitting there, and that is going to give us, let's see, multiplying the 2 up here, and that is going to be, theta is going to be 5 pi over 4. Okay, so we're going to rewrite this, and I'm going to plug 5 pi over 4 in for theta and rewrite it in our clever way, like so. And so we know that all of these, this angle right here and this angle right there, are going to turn into 5 pi over 4s, and then I just need to tackle them. Okay, so here we go. We got 1 minus the cosine of 5 pi over 4. Okay, I'm going to move this guy. Ooh, that didn't turn out well. Okay, I'm just going to erase that guy. Yikes. All over the sine of 5 pi over 4. Okay, and we don't have to worry about positives and negative signs for the original angle here, but we do have to worry about positive and negative signs when we are doing these out. Okay, so if we look, we're going to have 1 minus, okay, and the cosine of 5 pi over 4, if we recall, it's going to be over here, right? 5 pi over 4. And we got ourselves a reference angle of pi over 4. It's parked in tangentville, so both cosine and sine are going to be negative. So they're both going to give us a negative root 2 over 2. Okay. And let's go ahead and do the same steps that we did before, and see where this takes us. Okay, so I'm going to clean this up and go 1 plus root 2 over 2, because I got the negative divided by this negative root 2 divided by 2. Okay, and from here we are just trying to whittle things down and knock them out. So I want to combine these up the same way that we did in the last example, and that is going to give us up top 2 plus root 2 over 2 divided by the square root of 2, negative square root of 2 divided by 2. Okay, so now what we're going to do is we are going to let's go ahead and get rid of these fractions here. And there's a bunch of different ways that you could do this out, but I'm going to multiply the top and the bottom by a 2 here. And so those will cancel out with that and that. Okay, and we are going to end up with a 2 plus square root of 2 all over negative square root of 2. And then I think I'm just going to multiply the top and the bottom by a negative square root of 2, and that should multiply that out, and that should go ahead and get rid of the square root on the bottom and give us what we need here. So putting this on into the next part, I'm going to get, using the distributive property here, I'm going to get a negative 2 root 2 minus, and then it looks like I'm going to get just 2 all divided by 2. And so, wow, it looks like we can go even further. Ooh, this thing is never ending. And we can cancel each one of these 2's out because they're in common. So I could, for example, factor out a -2 and go square root of 2 plus 1 divided by 2, and now that goes out, and at the end of the day I should have this guy as my solution. Okay, wow, lots of arithmetic there. So again, if you plug this in and you plug this into your calculator, you should get the exact same results. Okay, and then our final example here, where we're going to just do a real quick simplification, and it looks like we have the squares of some, looks like some half angles here. So what I'm going to do is that I'm going to take the definition of these half angles right here, and I'm going to drop them in and see what shakes loose from there. So let me do that. Okay, so we square these guys up, and once we square something, this is a quality of life thing, is that if you square a plus or minus here, then those are going to go away along with the square root sign there, so we don't need to worry about those. So basically, we're going to end up bringing everything down. The 1 minus cosine theta divided by 2 times 1 plus cosine theta divided by 2. Okay, and now we have to FOIL out the top. Okay, and it's kind of like the difference of two squares, and you might have a good idea what's going to happen next here. Is that after we FOIL out the top, we're going to get 1 minus cosine squared theta all over 4. Okay, and then it looks like I'm out of room. I'm always running out of room on these things here. And so 1 minus cosine squared theta, again from the Pythagorean identity that we see a gazillion times, it seems like, that sine squared theta equals 1 minus cosine squared theta. So I'm going to substitute in the sine squared theta. And there we go, divided by 4. And it looks like that's about as far down as that we can take it. Okay, so that's going to conclude what we're doing for sum and difference formulas, double angles, and half angle formulas. And if you are going to go on to calculus next year, you definitely have to have those memorized out and how to work them and really understand where they come from, and how to rewrite them in a rewarding way. So try some of the practice that's going to follow. It might be a little bit difficult at first. Compare your answers with the answer key, and just do the best you can. If you run into a wall, you know where to ask. So that's how you do that. Now, see you in the next video.